Before we get into solving rational inequalities, it's helpful to talk about polynomial inequalities. In other words, simple things like this one. X plus 7 times x minus 7 is less than 0. And I just want to remind you how inequalities work in general. If I take this really basic one, x minus 6 is less than 0. We take that over here and we try to solve this and figure out what exactly the answer is to this equation. I add 6 to each side and I get omega is less than 6. Okay, that's my solution. It's not that omega is equal to a particular value less than 6, like 5 or 2. It's that it's less than all, omega is all the values less than 6. Those are all solutions to this problem. So the way we would plot that, if we wanted to say it on a line graph, is something like this. And you've probably seen graphs like this before, where you say, there's 6, except I wouldn't use a closed dot, right? Let's be a little more accurate about this. I would use an open dot because omega has to be less than 6 but not equal to it. And then I would just shade in all this area going all the way out into infinity. Okay? And the way I say that in interval notation is the following. I would say negative infinity all the way up to but not including 6. These are my solutions to that inequality equation, that inequality. Now I can try the same idea. I'm going to need more room for this guy. Hold on a second. So I'm going to try the same idea with this guy over here. So let's take this example, bring it down here. It's going to be omega plus 2 is less than or equal to 0. Now that's the difference. It gives me omega is less than or equal to negative 2, which if I make a line graph, what that looks like, I've got negative 2 here. And now it's a closed dot because all the values less than negative 2, including negative 2 itself, are acceptable solutions. The way I would say that is negative infinity all the way up to negative 2, including negative 2. So I would use this square bracket right there. Okay, so let's review. We're familiar with these things from polynomials. Now where it's getting a little more complicated is you have, well, in this example, I'm going to need more room here. You get out of my way. Okay, let's do this one first. This pair of factors multiplied together. If you actually try to figure out where this satisfies the condition shown here, where x plus 7 times x minus 7 is less than 0, there's different ways we could do it. We could graph it, for example. We could draw a graph and say, okay, well, what do I have here? I have an intercept at negative 7 and an intercept at positive 7, right? That's these guys. Negative 7, positive 7 are my x-intercepts. And it looks like it's going to be a positive even function, something like this, okay? Where my y-intercept, this is not to scale, by the way. That's negative 7. This is positive 7. My y-intercept is like negative 49. We've talked about this in graphing polynomials. And I would say, where is this graph less than 0? Well, it's this whole region in here, right? And the way you would say that in interval notation is this. You would say negative 7 to 7. And I use open parentheses because this is a less than sign, not a less than equal. Now, that's your answer, but we want a quicker way to do these things than just graphing everything, right? Graphs are fine, they work, but some of these things are going to start to get pretty complicated and you won't want to graph them. Although you could, it's just that, well, if the factoring is... Anyway, let's talk about a non-graphing technique. If you want to graph it, go for it. But I want to go over a non-graphing... Let's see if I can not move my y-axis. A non-graphing technique to come up with the same answer. And that is to use our number line. And on this number line, right here, I'm going to put every single x-intercept. Okay? There's negative 7, and there is positive 7. Now, along the right-hand side over here, I'm going to put all my factors. Okay, I'm using x instead of omega, but it's the same thing. Now, where is x plus 7 positive on this number line? Well, that's positive. Any number between negative 7 and positive 7 is positive. And anything less than negative 7, like negative 8, negative 9, negative 10, those will produce negatives here. I do the same thing with the x minus 7. I'm going to get positive, negative, negative, slightly different. And now I work my way down by multiplying these together, just like they're multiplied right here. Okay, so I get negative times negative makes it positive. Negative times positive makes it negative. and another positive over here. And I say to myself, where's it negative? Well, right there. That's negative. And that is from negative 7 to 7 on the number line. Okay, so there's an algebra technique. Instead of actually graphing the problem, we could just use this thing called, and here's the name of it, sine array. Okay, I've seen it called a number of different things, but usually people call this a sine array, which is just a way of keeping track of where the signs are changing, right? It goes from positive to negative and back to positive again. Those changes happen at x-intercepts. So let's do this example real quick. I've got, psi, I'm just going to write it as x. X squared plus 12x plus 35 greater than or equal to 0. Okay, I just moved everything over to the right. And now we factor and make this x plus 5 and x plus 7 is greater than or equal to 0. So instead of graphing it, if you want to graph it, go ahead. But I'm going to use this number line and say negative 5, negative 7. Okay, I need a little more space here. There we go. Negative 5 and negative 7. Here are my factors. X plus 5, x plus 7. And where are they positive? They're both positive above negative 5. Below negative 5, x plus 5 turns negative, but x plus 7 is still positive. And below negative 7, now they're both negative. So you multiply those together, and we get negative, positive. I'm just not doing this right today. We get positive, negative, positive. Okay, and since I want greater than, right, greater than 0, that's what we're trying to solve here, I'm looking for the positives. So here's my solution. It's negative infinity through negative 7. And because this is greater than or equal to 0, negative 7 itself is okay. So that means we've got a square bracket here. Union, square bracket on the negative 5 for the same reason, out to infinity. Okay, so that would be my answer. That would be the solution to this inequality.